Hi, welcome to Mrs. Park's Algebra 1 class. It's Chapter 6, Lesson 7, using matrices to solve systems of equations. Okay. So last lesson we learned how to add, subtract, and multiply matrices. And that was just a real simple in the bracket. We find the same dimensions. We can only add, subtract if they're the same dimensions, if they have the same dimensions. For instance, if it's 3 by 2, you can only add and subtract another 3 by 2. Okay, so today we're going to learn how to use these matrices to solve systems of equations. Okay, so why? So let's say you have 30 members of the Washington High School Ski Club went on a one-day ski trip. Members can rent skis for $22 per day or snowboards for $24 per day. The club paid a total of $700 for rental equipment. The resort can use this information to find how many members rented each type of equipment. So, augmented matrices. You can use a matrix called an augmented matrix to solve a system of equations. An augmented matrix consists of the coefficients and the constant terms of a system of equations. The coefficients and the constant terms are usually separated by a dashed line. So if we have a linear system, and you see here it's lined up with x and y's, so you can say this is a 1, -3, and 8 in the first row. And here, -9, 2, -4 in the second row. And you see a dotted line there. Okay. The coefficient and constant terms are usually separated by a dashed line. Okay. Make sure the coefficients of the x terms are listed in one column. These are the x's. The coefficients of the y terms are in another column. These are the y's. And the constant terms are in a third column. Here's the constants. Write an augmented matrix. So here you have, again, there's two equations. Okay, so you're going to put -2, 7, 11. There you go. 6, -4, and 2 in the second row. You have a dashed line there to make sure you know that those are the constant terms. Here you have x minus 2y equals 5. So you have your 1, -2, 5. And then you have nothing here for x. So you put 0, because there isn't anything that exists for x. So 0. This is a positive 1, -4. Okay. So here's your turn, numbers 1 and 2. Write an augmented matrix for each system equations. Go ahead and do that and come back when you are done. Okay. Key concept. Elementary row operations. The following operations can be performed on an augmented matrix. You can interchange any two rows, multiply all rows in the elements in a row by a non-zero constant, replace one row with the sum of that row and a multiple of another row. Okay. So row reduction is the process of performing elementary row operations on an augmented matrix system to solve a system. The goal is to get the coefficients proportion of the matrix to have the form 1, 0, 0, 1, also known as the identity matrix. The first row will give you the solution for x because the coefficient of y is 0 and the coefficient of x is 1. The second row will give you the solution for y because the coefficient of x is 0 and the coefficient of y is 1. Okay, so when we're using row operations to solve an equation or solve a system, we have these augmented matrix to solve the system equations. So here you see -5x plus 3y equals 6 and x minus y equals 4. So again, for us to use augmented matrix, we're going to rearrange this. So it's -5, 3, 6 is the first row. 1, -1, and 4 is the second row. And you see these dashed lines here in the matrix that tells us that 6 and 4 are just the numbers, the constant. Alright, so once we arrange this in augmented matrix, step 2, notice that the first element in the second row is 1. We're talking about this one here. Interchange the rows so one can be in the upper left hand corner. Oh, okay, so this one here, they want it to be on the upper left right here. Okay, so they changed the rows there. A little thinner. Okay, so all it did was change rows 1 and rows 2. They flipped it upside down. Okay, to make the first element in the second row a 0, multiply the first row by 5 and add the second row and add this result to row 2. Okay, so the first step they did was the second row, they multiply the first row by 5 and add the result to row 2. Okay, so in order to make this a 0, multiply the first row by 5 and then add it to the second row. So times 5 is 5 plus negative 5 is 0. Negative 5 times 5 is negative 5 plus 3, you have negative 2. 4 times 5 is 20 plus the 6 is 26. To make the second element in the second row a 1, multiply the second row by negative 1/2. So they want the second element in the second row a 1. So in order to make this negative 2 into a 1, you multiply by a negative 1/2. So negative 1/2 times everything in the second row. 0 times negative 1/2 is 0. Negative 2 times negative 1/2 is 1. 26 times negative 1/2 is 13. To make the second element in the first row a 0. Second element in the first row. Okay. So they want this negative 1 to be a 0. You add the rows together. So you add these two, add these two, add these two, and results go into first row. And the solution you have here is negative 9 and 13. And that's our answer here. Okay. So all these steps are really complicated, but what they're really trying to do is try to make this here into a 1, 0, as we did in this previous slide. Oops, I shouldn't have put that comma there. Okay. They're changing everything in the matrix so that it looks like 1, 0, and 0, 1. And then whatever you have as your answers here is the solution. Okay, just like the previous slide, it said 1, 0, 0, 1 is the identity matrix. And whatever coefficient you get, you have to multiply in order to get this. You do to everything else. And the goal is to have the answers in the last column. Okay. So here are 2 more examples that we can do together before I give you your turn. So here's number 7 and 8. Alright, so number 7. Let's rearrange this into an augmented matrix. So you have 1, 1, negative 3, 1, negative 1, and 1. Okay. Remember, our goal is to make this look like you want a 1, 0, 0, 1, and then your X and Y is there. So ultimate goal, you already have 1 here, so make that into 0, make that into 0, make that into 1. Okay. So first, what am I going to do? I'm going to do row 2 minus row 1, and that will give me 1 minus 1. Okay. So I didn't do anything to the first row here. I'm going to leave it at that. So second row, 1 minus 1 will give me 0. Okay. Negative 1 minus 1 will give me negative 2. 1 minus 3 will give me negative 4. Okay. So all I did was rearrange the second row by doing row 2 minus row 1 and arranged in row 2. Okay, second step I'm going to take, now I like how I have 1 here and 0 here. I want to make this into a 0. So what I'm going to do is I'm going to multiply the second row by half, row 2, and then I'm going to add that to row 1. Okay. So now my first row is going to change. I'm going to multiply this by 1/2 and add it on here. So 0 times 1/2 is 0. Added to 1 is 1. Negative 2 times 1/2 is negative 1. Added to 1 is 0. Negative 4 times 1/2 added to negative 3 makes it negative 1. Okay. And my second row will stay the same. 0, negative 2, negative 4. Alright, so far I have 1, 0, 0. And I need to make this negative 2 into a positive 1. Okay. So in order to make this into a positive 1, I'm going to multiply the second row by negative 1/2. So if I multiply everything in the second row by 1/2, I'm going to get, so again, I didn't do anything to this top one. It's 1, 0, negative 1. So bottom row here, I'm going to multiply everything by negative 1/2. So that's say 0. Negative 2 times negative 1/2 will become 1. Negative 4 times negative 1/2 will become negative 2. Okay. So now I have here my 1, 0, 0, 1 here as my x and y's. So this is your answer part. So your answer here will go as negative 1 and negative 2. And that's my answer. Okay. So let's try another one here. Okay, so let's move on to number 8. So again, what we're going to do here is we're going to rearrange these matrices into augmented matrices. So I'm going to start over here. Oh, that is way too big. Okay, let's erase that. Alright, so we have here 1, negative 1. Oops. Make it a little bigger. Okay, we have 1, negative 1, 2, negative 2, 2, 2, and 12. Okay. So again, what we want to do is make our matrix look like we want our matrix to look like 1, 0, 0, 1, and whatever numbers come here and here. Okay. Okay. All right. So first step we're going to do is multiply the second row by 1/2, and then subtract it from the first row. So R2, we're going to do 1/2 of R2, and then minus R1. Okay, so 1/2 of this will be 1, and subtract 1 from that 1 will be 0. So, yeah, the first row we didn't touch. Okay, second row we got a 0 here. 1/2 of this is 1, and minus the negative 1 will make it 2. 1/2 of 12 is 6, and minus the negative 2 will make it 8. So I have my 1 here and a 0 here. That's what I like. Now I'm going to make this into a 0 by doing 1/2 of R2. Okay, and then I'm going to add it back to R1. So 1/2 R2 plus R1. Okay, so my bottom 0 to 8, my bottom row is the same. Okay, so 1/2 of this is 0. Added to this, you still have your 1 there. 1/2 of 2 is 1. add to negative 1. 1 plus negative 1 is 0. 1/2 of 8 is 4, plus the negative 2 makes it 2. Okay. Next step up here. Okay, so I have my 1 and 0 is 0, and I need to make this into 1. I'm going to multiply the second row everything by 1/2. So my next step is my second row, I'm going to multiply by 1/2. My first row stays the same, 0, 1, 0, 2. 1/2 is 0, 0. 1/2 of 2 is 1. 1/2 of 8 is 4. Okay. Now that I have my 1, 0, 0, 1, I can say this is my answer, 2, 4. So my order pair is 2 and 4. Okay. So this is just adding one more step into how to solve for a solution when it comes to system equations. Before, in this chapter, we learned how to solve system equations by graphing. We did substitution. We did elimination by adding or subtracting. We also multiplied to make sure we were able to eliminate by adding and subtracting. And now we're adding one more step using matrix to solve. What this means is when you graph these two graphs on a graphing paper, the two lines that they meet at one point, and that's going to be 2 and 4. Okay. All right. So next is your turn. If you're not sure, go back to these videos, review it before you do it. But here is your turn, numbers 3 and 4. So don't go ahead and do this on a separate sheet of paper, and come back when you are done. All right, so welcome back. We're going to try some real-world examples. Number 3, parks. A youth group traveling in 2 vans visited Yellowstone National Park. The number of people in each van and the park fees are shown in the table. So here are your numbers. Okay. So the van A and B, number of adults, number of students, and total cost. So you have 26102, 27114. Here's your matrices. Okay. Write a system of linear equations to model situation, then write the augmented matrix. So here's your augmented matrix. Okay, so what are you going to do? Find the interest fee for an adult and a student. So really they're asking for x and y. So again, we're going to want this to be 1, 0, 0, 1, and whatever numbers you find here will be the answer. All right, so what they did was to row 1, they multiply everything by 1/2 to make that into nice 1. So 1/2, 1/2, 1/2. Here are your numbers. Second row stays the same. All right. Now they want the first element in the second row to be a 0. So what they did here was multiply the first row by -2 and then add it to here. So 2 times -2 is -2 plus 2, you get 0. Multiply 3 by -2 is -6 plus 7 is 1. 51 times -2 plus 114 is 12. So here I have a nice 1 and a 0. Next step, I want to make this into a 0. And how do I do that? Well, multiply the second row by -3 and then add it to the first row. So times -3 is 0, add it to 1, you have 1. 1 times -3 plus 3, you got your 0. 12 times -3 plus 51, you get 15. Okay. Now you have a 1, 0, 0, 1. So your answer is 15 and 12. So 15, 12, so that means adult fee is 15 and student fee is 12. Okay, go ahead and do your turn number 5. Here's the carnival situation here. So go ahead and put these numbers into a nice matrix, augmented matrix, then solve for your x and y. Okay, and that is the end of the lesson. So go ahead and submit your paper tomorrow for your homework credit. And thanks for watching.